Morning, ladies and gentlemen. I figured I would start making some weekly videos that go along with your weekly assignments. This weekly video is for the week of April 20th. We are talking about types of solutions to equations and systems. So if you are not on that today, or if you are working on past week stuff, then you can get extra help by contacting me, or you can look at that helpful video page on Schoology. It's under each week that have videos that are specific to what you are working on for that specific week. Okay, so I'm going to be looking for the materials through Schoology. You can also access them through the Gowanda Central School District website, but I also post everything on Schoology. As you know, that you can click on the Learning from Home folder, and that will take you straight to our weeks. As of right now, the weeks are unpublished because I'm doing this ahead of time, but week of 4/20/2020 will be available on the 19th, which is Sunday. So when we click on that, let's just take a look at what we're doing this week. Okay, remember I break it down for you on a daily basis, but if you want to get more or less done in a day, that's totally fine. So on Monday, I do want you to check over your work for the not the previous week, because the previous week was the spring break challenge, but from 2 weeks ago. And that's going to be pages 1 through 3 in the packet. But before we get to the packet, I want to just make another announcement. I've been making a lot of announcements like this lately, but I want everyone who is able to sign up for Remind 101. The reason that I'm pushing this so much is because it makes it 10 times easier to help you guys with any math problems that you're working on. It's just like texting. You just can send me a picture of your work and I can send you a picture of where you went wrong or things you did great. You're texting your teacher without knowing your teacher's phone number, and vice versa. I don't know your phone number either. So 2 different ways of signing up. First way is if you have a smartphone, you can get the application. And I think on the left-hand side of the app, when you open it, it will take you to settings and you can join a class. And the class code is this F9BK2G. If you don't have a smartphone, or if you just want to sign up through texting, which, data rates and text messaging fees apply for this. So if you don't have unlimited text messaging, just keep that in mind. All you have to do is text at F9BK2G to the number 81010. And there's an example of that right there on this information sheet. That information sheet should be sent home to you, and it should also be on the Google Docs, and it is in Schoology. I've also mentioned it many times in our course updates. Okay, going back to Schoology and going back to our list here of things to do, I'm going to click any of these links takes you to the same packet. You're working out of one packet. I changed my formatting a couple of weeks ago so that you only have one thing to work out of. Hopefully that's going to be easier for you to complete. Okay, so I'm just going to kind of give you a brief overview. This video is not meant to be watched while you're doing everything. This is an overview of what you are doing for the week. Okay, so taking a look at our Monday's work, you can see that this is all checking your answers from the week of April 6th. So the first page from that week was solving by graphing. Remember, you have to get the y values by themselves, and then you can graph them, finding the y-intercept, and then graphing the slope. Remember, slope is rise over run. The solutions to systems of equations is the coordinate where they intersect. Also keeping in mind number 4, where it said y equals -1. I just want to rewrite this for you so you can understand where this comes from. It's basically saying y equals 0, x minus 1, telling you that the slope is 0 and your y-intercept is -1. So if you have a 0 slope, that means you're walking on a flat surface. So that's why we have this straight line going across for the equation y equals -1. Okay, on the next page, it's basically the same idea, except you can see that these equations do not have y by themselves. So what you have to do is you have to get y by itself. And so you would subtract 5x for that first example. You can see I do that You can see I do that in the top portion of these notes. Then we go through the substitution method. Now I did not show, I did show my work when I solved these problems, but to condense space and so you didn't have such a big packet, I just wrote answers down here. But remember, the substitution method means that you have to have one variable alone in order to solve an equation. So like an example would be y equals 5x minus 1, and let's say 2x minus 3y equals 10. Okay, you can see that top equation has a variable alone, so that indicates that we should do the substitution method. However, you can do the substitution method with any system. You might have to get a variable by itself first, though. Okay, so for this example I just did, I'm not going to do it all. I don't even know if it would work, but so we would put what the variable alone is equal to into parentheses. And that's what y is equal to. So we're going to replace the y with the parentheses. So we've got 2x minus 3, and my y is 5x minus 1 equals 10. Draw your line down, distribute, solve for x. That's the substitution method. Okay, for the elimination method, remember your variables have to line up. So like you need an example, like I'm just creating these on the spot here. 3x minus 2y equals 10. Okay, so for this example here, you eventually are going to have to add the equations together. But before you add the equations together, you have to make sure that a variable will eliminate. So I'm just going to pick the x's to eliminate for this random example I came up with. So we need same coefficient, opposite signs. That's the key. Same coefficient, same number in front of the variable, opposite signs. One needs to be positive, one needs to be negative. Okay, so right now I'm looking at the 2 and the 3. Those are not the same. However, I know that they both multiply to 6. So I'm going to manipulate the equation so that it becomes a 6. So I'm going to multiply this. When I multiply the 2 to get to 6, I have to multiply by 3. And the bottom has to be multiplied by 2. And in order to get opposite signs, you just tack a negative onto one of those. It doesn't matter which one. Distribute to every single piece, then add your equations together. Okay, so all methods, solving system, all methods is just using all of those methods that we just practiced. Now, if you're doing one system like we are here, if we are doing one system using 3 different methods, so this is the one system that we're doing to do through the graphing, elimination, and substitution methods, we should all get the same answers. So that's why all of these answers are 3, 4. Okay, so now moving on to the rest of this packet. A lot of this has to do with the types of solutions. Remember, types of solutions means there's one unique solution, there is infinitely many solutions, or there are no solutions. Okay, so I'm just going to kind of walk through this first one with you. Okay, it says that consider the slopes and the y-intercepts of each system of equations. Determine if things are true or false. So this first equation, we have y equals 3/4 x plus 6, and y equals negative 3/4 x plus 5. And they're telling us that it has one solution. Okay, so if you look at the y-intercepts, you look at those y-intercepts, the 6 and the 5, those are different. So that means one of the equations starts at 6 and one of the equations starts at 5. Okay, so I'm just sketching this over to the right here. It's going to be really sloppy, but I'm going to try my best. Okay, then when we look at the slopes, we've got 3/4. So that's a positive slope. I'm just going to estimate that's the one that goes along with 6. So that's going up somehow. And then negative 3/4 is a negative slope. So that means it's going down. Okay, so I see the solution right here. Okay, and that intersects in one spot. So yes, it does have one solution. So that one is true. The next one, okay, the y is not by itself in this first equation. So you're going to have to solve for that first. Okay, but just keep in mind, if equations have the same slope, that means they have the same steepness. So if I have an equation that looks like this, or a linear function, that's the line of it, and then I have another one with the same slope, a different y-intercept because they have to start in different spots, that means that they're parallel. So that means they're never going to intersect, going to have no solutions, okay? If something has an infinite number of solutions, that means that it is literally the same exact equation, the same exact line. Now, if you look down to other equations like this one, it says consider the equation, and it's got all this stuff here. You're going to have to distribute and solve it. Just keep in mind, I'm going to make a little note down here for you, that if you get something at the end of your solving that looks like x equals 3, pretty basic, pretty simple. That means there's one solution, okay? However, if you get something like x equals x, 5 equals 5, 0 equals 0, now all those things make sense. 5 is equal to 5. However, it's weird how it solves itself. So this is infinite solutions. And if you get something that makes absolutely no sense, like 5 equals -3, that is not equal. Anything that does not make sense at the end means that there is no solution. Okay? That's a lot of this work that you are working on for this week. We've got some more solving by graphing. Now, if it says solve the system algebraically like it does here, all that means is that it means you either have to solve it by using the elimination method or the substitution method. It doesn't matter which method you choose, but algebraically means one of those methods. Okay, we've got some word problem stuff. Now this one, number 5 on page 6, is kind of a blast from the past. It talks about similar figures here. Remember, similar figures are proportional. So if I have a figure that looks like, oops, let's not do that highlighter. Erase, please. If I have a rectangle and then a larger rectangle, I'm just going to put some measurements on here. Okay, hopefully you see the pattern here. 5 times 2 gives me 10, 2 times 2 gives me 4. They have the same scale factor, so those figures are similar. Similar means they have the same shape, same angles, proportional side lengths. So keep that in mind when you're doing that problem. Got graphing, slope. Remember, if you need to calculate slope in any situation, you can either do rise over run, so slope is the m, rise over run, or remember that slope formula, you need 2 points in order to do the slope formula. Label them x and y, first point and second point. Again, this is talking about infinitely many solutions, which means if they're infinite, that means they are literally the same line. So here's, I'm graphing one line, then I graph the next line and I realize, oh, that's the same thing. So that means they would be the same exact equation. But if you need to figure out which equation is going to be exactly the same in number 7, you might have to move some things around and do some solving. I think I have pretty much covered everything that you're going to be working on for this week. I encourage you to contact me through Remind 101. That's my #1 preferred way of contacting me. Or you can always send me an email. You can call my school phone. I'll get back to you as soon as possible. It's 532-3325, extension 5108. Schoology message. However, the Schoology messages on my phone and like through the app, they're really delayed. So I'll get your message, could range from 30 minutes to the next day that I get your notification for your message. So it still works. It just might take some more time. But that's all I've got for you for today. So if you have any questions, let me know, and have a great week.